All right, so let's finish up with this last one. Thanks for stopping back in. We're going to graph h of x and compare it to the graph of f of x. So you can continue to always, when you make your table, if you want, you can put f of x in there. It's not critical though. We're really only concerned, because we know at this point all of our f of x values, we're really just concerned with our h of x values. But keeping with the same x coordinates we've been using, I know that f of x, meaning when I say that, it's just x squared. So negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. I know that. So that's why I said it's not imperative that you write it, but you're welcome to. All right, so this is my parent function. All right, so now when I look at my new function, h of x, it has an a value, so that means there's definitely a stretch or a shrink. And then it has a c value, so that means it's either moving it up or down. We're just going to see what happens. So what I would recommend you actually do to find these points, you might have an idea of what's happening. Hopefully in your head you can think, well, what's this number going to do and what's that number going to do? And then test it out and see if you're accurate. So, but I would say just go ahead and literally just sub those numbers in. So it was 2x squared plus 4. I'm going to do sub negative 2 in and get my answer. So this, I have to use PEMDAS. So that's negative 2 squared, which is 4. Do my exponents first. So I have 2 times 4, and then this plus 4. So 2 times 4 plus 4. 2 times 4 is 8, plus 4 is 12. So that's my first point, negative 2, 12. All right, next I'm going to do the same thing. I'm going to substitute a negative 1 this time. All right, so negative 1 squared is 1. So I have 2 times 1 plus 4. 2 plus 4, which is 6. So now I have negative 1, 6. 2 times 0 squared plus 4. 0 is always a nice one because 0 times anything is 0. So I have 0 plus 4, which is just 4. So this point is 0, 4. Then we have, just to double check them, we have 2 times 1 squared plus 4. Order of operations. I square that, so now I have 2 times 1 plus 4. 2 times 1 is 2, plus 4 is 6. So my answer is 1, 6. And my last one, 2 times 2 squared plus 4. 2 squared is 4, so this is 2 times 4 plus 4, which is 8 plus 4, which is 12. Okay, so my answers are, that order pair is 2 12. So negative 2 all the way up to 12. Then we have negative 1 up to 6. We have 0 up to 4. 1 up to 6, and 2 up to 12. Okay, so here's what happened. Now at the first point I said that it looked like, or what I could conclude was based on this here and here, each of these did something, and that was accurate. So the 2, if I write it like that, the 2 caused, maybe in a different color, the 2 was the a value, and so that caused a vertical, it got narrower, so it's considered a vertical stretch by a factor of 2. And then the 4 was my c value that shifted the graph up 4 units. Okay, all right, so just to confirm that, let's go ahead and look at Desmos. But I do want to point out one thing from way back when we learned function notation. We learned that when we started learning like what f of x and h of x, a lot of people ask, why can't we just use y? It works so well, and it's true. But by using these different functions, now I could on my graph here just label this h of x and this f of x, and it makes it a lot clearer. And you can imagine if you have more than one function, you have a couple of them maybe, or even like 5, it can make it a lot better than just having y's everywhere. All right, so let's just look lastly at Desmos. I have the graphs up here. So then red is our parent function. Then I typed in what the function is that they're actually asking us to use, h of x. And I just did a slider just because I want us to see how it translates. So like see that in action. So if I go back to just just x squared. So it's like 1x squared plus 0. This is our function, our parent function. Now, my a value is actually 2. So let's see what happens whenever I make that 2. My graph gets narrower, and that's what we saw happen. And let's see when we have our c value of 4. It's going to take this graph and just shift it all the way up 4 units. And those are the points we had. All right, great work. Thanks for stopping in. Bye, guys.